A continuing problem in conservation is the lack of science-based knowledge on which sound management decisions can be made. A total of 4 MFF-SGF projects focused on research. In the north and east, where up until a few years ago, access was difficult because of the civil unrest, the generation of science-based knowledge and scientific research has suffered. 2 projects of the SGF began to redress this issue by looking at groundwater quality in the Panama area and studying mangroves in Portugal. Although about 70% of the earth is covered by water, much of this water is unusable. Only 3% of all the world's water is fresh water. Of this fresh water, 2% is trapped in ice, leaving only 1% of this planet's fresh water to support all life on Earth. In Sri Lanka, in the dry zone, where rain is sharply seasonal, underground water contained in porous rocks is the only continuous source of fresh water. Water demands in the Panama area are now increasing as a result of an increasing demand for domestic and agricultural activities. The groundwater study, funded by the SGF and conducted by the Postgraduate Institute of Science of the University of Peradeniya, showed that there is a high concentration of sodium, potassium, calcium and magnesium in the groundwater. High sodium indicates that there is saltwater intrusion, and other chemicals, particularly nitrogen, indicate pollution from agricultural sources because nitrogen is a key component of fertilizers. The study showed clearly that reliable and regular data are invaluable to guide improved performance. The researchers recommend that creating awareness about groundwater and proper management of this meager resource are critical for the area. Mangroves make up one of the world's unique ecosystems because they thrive where no other trees can survive, in the transition zone between the ocean and dry land. Mangroves give us food, fuelwood and medicines, and they protect us from extreme weather events, regulate floods and absorb carbon dioxide from the atmosphere. Yet, mangroves all over the world are under threat from a range of human activities. The Postgraduate Institute of Science of the University of Peradeniya, under the aegis of the SGF, conducted a survey of mangroves in Panama, Helava and Okanda lagoons on the eastern coast of the island. Their study showed a luxuriant growth of mangroves along the fringe of the Panama lagoon, but relatively small extents in Helava and Okanda. In Panama, the mangroves are dominated by Avicennia marina, Lumnicera racemosa and Rhizophora mucronata. The Helava lagoon mangroves, damaged severely by the 2004 tsunami, are showing no signs of recovery. Here, the dominant species is Lumnicera racemosa. The study also looked at fisheries in the Panama lagoon and found that about 45 species of fish are harvested, but only a few species such as tilapias, mullets, silverbellies and catfish form the bulk of the catch. Mangrove crabs and prawns are also caught seasonally. The researchers warn that there is a great danger because of ongoing development that these mangrove areas will be cleared. They recommend that boundaries of mangrove areas in this region must be demarcated clearly. Their study confirms that improving the knowledge base always helps in improving management. Sea grasses are flowering, rooted plants which grow underwater, exclusively in coastal marine waters and coastal brackish water wetlands. Like grasses in terrestrial habitats, they form meadows on the beds of shallow coastal seas, estuaries and lagoons. Seagrass meadows are ecologically and economically important habitats critical in coastal productivity and fisheries, also acting as filters, stabilizing the flow of coastal areas, cycling nutrients and absorbing carbon dioxide. 15 species of sea grasses have been recorded in Sri Lanka. There may be more species, but little is known about sea grasses in Sri Lanka. Through the SGF, the Department of Oceanography and Marine Geology of the University of Ruhuna assessed the diversity of seagrass species in the Puttalam Lagoon. 8 different species were observed during the study. Also observed was a range of anthropogenic threats: pollution from agricultural runoff, domestic waste and shrimp farms, damage to seagrasses from propellers of boats, and illegal fishing methods, as well as illegal construction near the shoreline. The researchers recommend publicizing the importance of seagrasses for fishing livelihoods, demarcating and declaring as no fishing, no access zones areas of undisturbed seagrass meadows, protecting islands with extensive mangrove and seagrass habitats, and prohibiting harmful fishing gear. These projects, funded by the SGF, have served to improve the knowledge base on groundwater, mangroves and seagrasses, each of them different, but all equally important in contributing to providing science-based knowledge on which management decisions can be made.